Hello all, myself is Dr Dhanya P M, Assistant Professor of the Department of Computer Science and Engineering, the Agility School of Engineering and Technology. Today I will be dealing with threads in Java, which is coming under CS206 Object-Oriented Design and Programming under KT syllabus in semester 4. So let's see the table of contents. First of all, we will see what a multi-threading is, then the different states of a thread, creation of a thread, different thread methods, sample programs using thread methods, and finally synchronization. Now what is actually a thread? A thread is actually a sequence of statements which can be executed without conflicting with other sections of the program. So it has its own sequence of execution, and if you could identify such threads in a program, then all such threads can be executed concurrently. So a parallelism can be achieved in your program. So multi-threading is actually a special form of multitasking. Now, but how we can parallelize it? This is actually done by utilizing the idle time of CPU. That is, when you consider that a program is making use of a local file system or any I/O operation, in that case, the speed of such an operation will be very less when you compare with the speed of a CPU. So CPU will be sitting idle that time. So such idle time of a CPU can be utilized and it can switch to some other thread and execute it. So that is how we make use of implement parallelism. So this multi-threading actually it is a type of multitasking. So we can divide this multitasking into two. One is process-based, another one is thread-based. Now in process-based, we are running many programs concurrently, but in thread-based, many threads are run parallelly. Now process-based multitasking means you are seeing that you are running a Java compiler at the same time you are visiting a website. Now thread-based means you are formatting your text at the same time while it is printing. Now processes, when you consider processes, these are heavyweight tasks that requires their own address space, but the threads are lightweight tasks. Now, the inter-process communication is very expensive, and the context switch between these threads, between the processes, is also expensive. Now, when you take the context switching, in the case of thread, it is very low cost. Now, these are some real-life examples of multi-threading. That is, multiple tabs opened while you are browsing net, or you are typing in MS Word at the same time you are listening to music. You consider a game where several objects are moving at the same time, either ticket reservation where multiple customers are accessing at the same time, multiple account holders for accessing an account. Now let's see different stages of a thread. That is, the first stage is new, that is a thread object is created. Now when a start method is called, it will move to the runnable state. Now, when a start is called, this run method is automatically called and it will go to the running stage. Now, it will be terminated when the run method exits. Now, while running, if it encounters a sleep method, it will go to the block state or otherwise non-runnable state. And if the sleep, when the sleep is done, that the sleep is done for a particular millisecond, you can pass a millisecond as an argument. And when that time is over, the sleep is over, and will again move to the runnable state. So these are the 5 states of thread. So we have already seen the stages new, runnable, running, non-runnable, and terminated. Now, how to create threads in Java? Actually, threads can be created by 2 methods. One is by extending the thread class, another one is by implementing runnable interface. And actually, thread class is providing a lot of constructors. The thread constructor without any parameter, thread constructor with a name, with the argument runnable, and with 2 arguments. So these are the 4 constructors of the thread class. So this is a built-in class in Java. Now we'll see the different methods in thread class. That is the run method, which performs the actions for a thread. Then start, the thread starts execution, and the start in turn calls the run method. Now you have the sleep function where sleep method where you can pass the milliseconds as an argument. Suppose I give 1000 here, that thread will sleep for 1000 milliseconds. Its execution will be temporarily paused. And join means it waits for a join method will wait for a thread to die. Then join with argument can also be given. Then get priority returns priority of the thread. You can get a name using get name. You can change the name of a thread by using set name. Then current thread returns the reference to the currently executing thread. You can get the ID of the thread using get ID method. Now there is get state. You can get the current state of the thread. Then is alive. You can check whether the thread is alive or not. In yield. It causes the temporary pausing of the pausing of execution. Now, in that case, the opportunity will go to the other threads available, and that is decided by the thread scheduler. Now, suspend is used to suspend a thread. Then resume used to resume the suspended thread. Then there is stop, interrupt. Then you can check whether the thread is interrupted or not using is interrupted. Then this interrupted us to check whether the current thread has been interrupted or not. So these are the methods related to thread. In that we will be dealing with these run, start, sleep, join. Okay, these are the main methods we are going to deal with in the coming programs. Now let's see a simple example. We have written class sample thread extends. So this is the first method of creating a thread. Either you can extend thread class or otherwise use runnable interface. So this is the first method. So here I have written the run function. In that we have a statement thread is running, and here we are creating a thread object T1 and T1.start. So as I said, whenever we call start, this run will be automatically executed. So let's execute this program. So here we have a sample thread which extends the thread class, built-in class. And here the run function is there, and we are starting the thread. So you got the message, thread is running. So here in this program, in the run function we have written the message thread is running. So whenever you have created a thread object, you started it, and this run is automatically called. So this is the first method. You are creating a thread with by extending thread class. Now we'll see the second method. That is, you can implement runnable. That is, runnable is an interface. That is why you are using the keyword implements. So the same program, but this is slight difference. You are creating this object of this, and this is passed as an argument to the constructor of the thread class. That is st1 is passed as an argument to the constructor of your thread class. Then we apply t1.start, and this run will be automatically called. So let's run this program. So you got the message thread is running. So this is a second method by implementing the interface runnable. So you have to always keep in mind that whenever you start a thread, this run will be automatically called. Now let's see sleep method. So here I have written a program where you have a class test which extends your thread built-in thread class. I have included a run method In that we are trying to print I, which is varying from 0 to 4. And the sleep method is included. That is thread.sleep. The sleep is actually a static method. That is why we are calling it using the class name dot method name. So sleep for 500 milliseconds. So this is whenever a sleep is encountered, the current thread will be suspended and the control will go to the next thread. So here in the main function I have created two thread objects T1 and T2. And I am starting both T1 and T2. T1 dot start, T2 dot start. Now, whenever, so first of all, T1 gets started and this run is automatically called. It will print I and it will encounter sleep. It will be suspended. The second thread will take over and you can see that when the second thread works, it will again go to sleep and the first thread will take over. So here you can see that the output is interleaving. Both the threads are working at the same time. That is, when one thread sleeps, the other thread will work. So let's run this program. So here two threads are there, T1 and T2. I have started both the threads, and this sleep method is included within a try catch because there is a chance of an interrupted exception. So we have to include the sleep method within a try catch block. So you can see that both the threads are working simultaneously. At a time only one thread is working. When one thread sleeps, the other thread takes over. That is what is happening here. It is utilizing the idle time of CPU, and you can see that the output is coming in the interleaved fashion. Now, when you start a thread, you can start a thread twice. This is an error. That is, this will cause a runtime error. That is, here I have created a thread object T1 and I have written T1 dot start and again I have started it. This will create a exception. The first time it will work, you will get the output, but the second time it will call a exception. Now what happens if you are directly calling run? So here I have created a thread object T1 and instead of T1 dot start I have called T1 dot run. Now the problem is each thread starts a separate call stack. But if you are invoking the run method directly, what happens is the run method goes to the current call stack rather than at the beginning of a new call stack. So the problem is, you take this case where you have I have two objects, thread objects T1 and T2. I have called T1 dot run, T2 dot run. In this case, both this T1 and T2 will not be considered as thread objects, but they will be considered as normal objects. And you can see that the output is getting as one only after executing one thread you will get output of the second thread. You won't find any interleaving here. There is no context switching in this case. Both the T1 and T2 are considered as normal objects. Now, thread priorities. So in Java, priority is assigned to each thread. And these thread priorities are nothing but integers that specify the relative priority of one thread to another. And a thread's priority is used to decide when to switch from one thread to another. And this is actually called context switch. And there are certain rules for this context switch. Now a thread can voluntarily give control by using the methods sleep or otherwise yield. And if a thread is preempted by a higher priority thread, that is called preemptive multitasking. Now, if suppose a case occurs where two threads with the same priority are competing for the CPU cycle, now in the case of Windows, both the threads with the same priority will be time sliced and they will be performing in a round robin fashion. Now, main thread. That is, every Java program is having an implicit thread. And it is a first thread that is being executed when a Java program is executed. Now, it is from the main thread, other child threads are created, and it is also the last thread that finishes execution. So let's see one example for that. So here you can see a program where you created class tTest, you have written the main function, and you are getting this current thread, this method will return the ID of the current thread, and we are getting the name of that thread, and we are displaying that name, and here using set name and changing the main thread's name to my thread. Okay, so first of all it will display the thread's name as main, which is the implicit thread in any Java program. Then I am setting its name to my thread. So let me execute this program. So you can see that the output, you got the main thread name as main, and then I have changed the name to my thread using set name. Then now let's see the main thread and child threads. So here you can see I have written a class test extends thread class, and I have written a run function where I am printing from 0 to 4, and I have included a sleep method where the sleep is for 100 milliseconds, and that is included within a try catch statement. And here I am accessing the ID of the main thread, and I am getting its name. Then I am creating 3 child threads also, T1, T2 and T3. And I am starting on 3. T1 dot start, T2 dot start and T3 dot start. So what happens is, when you try to print the main thread's name, you will get the output as main, and the 3 child threads will be having the names of thread 0, thread 1 and thread 2. And you can see that the output is got in an interleaved fashion. So let's run this program. So here is a program with the run function which prints from 0 to 4. I included the sleep with 100 milliseconds, that is when one thread sleeps, the other will execute. Likewise we have 3 child threads, T1, T2 and T3. So you can see the output where the main thread name is main. As I said, every Java program is having an implicit thread which is our main thread. The name of that thread is displayed. Then I have created 3 threads, child threads, thread 0, thread 1, thread 2. Now you can change this thread name using setName function. Now I have started all the 3 child threads, and you can see the output which is coming in the interleaved fashion. All the 3 threads are working. Now here is join method. Now the purpose of join method is when join method is called, it waits for a thread to die. That is called, suppose I call t1.join. It's the same previous program where you have the three threads, child threads t1, t2 and t3, and I am calling and starting thread 1 t1.start. Then I am calling t1.join. That is put within a try-catch statement. When I call t1.join, it will wait for t1 to complete. That is, only after completing t1, t2 and t3 will start. That is, you can see the output as t1 is started first and it will wait, the join function will wait for t1 to complete. So only after completing t1, your t1, the next t2 and t3 is starting. Okay, so t1 completes first, then comes t2 and t3 interleaved in an interleaved fashion. So let's see the outputs. So you can see T1 is executing first and only after executing T1, your T2 and T3 is executing. This is possible by using the method join. The next is synchronization. Now you are seeing a situation where there is a data structure which is going to be shared by all the threads. And if suppose you have a linked list or some table or something where one thread is writing and the other threads are trying to read. Now in such a situation it will create a conflict. So you want to protect such conflict. In that case, Java has a mechanism called using monitors. It is monitors nothing but it is a small box that can hold one thread. That is, once a thread enters a monitor, no other threads are allowed to enter that monitor. Now, let's see. Now, this is called thread synchronization. Now, mainly Java has two methods for thread synchronization. One is mutual exclusion and the second method is cooperation. And this mutual exclusion can be done in three ways: synchronized method, synchronized block, and static synchronization. So in a syllabus you have to study the synchronized method and synchronized block. So let's see synchronized block first. So here I have a class table which extends the thread class, and I have a method called print table. Now this print table is going to be accessed by two threads. One thread will, the purpose of this print table is to print the multiplication table of a number. That is multiplication table of n. It will print up to 5. Okay. So, and I have given a sleep for 400 milliseconds. And now this print table is actually a shared method. Now, I am creating my thread 1 and I'm creating a reference of the table, and in the constructor I am assigning this dot t equal to t. Now I am calling from here, from the run method, I am calling t dot print table 6. That is, the first thread is going to print the multiplication table of 6. And I have created the second thread where it is going to print the multiplication table of 100. So one thread will print the multiplication table of 6. The second thread will print the multiplication table of 100. So both are going to access the same method, print table. which is written here. Now I have created this T1 and T2 and I am starting both T1 dot start, T2 dot start. So here now when both the threads are trying to access the same method, I want to lock it. That is, this is done by, I said you can use a synchronized block. So here, this is a synchronized block. The syntax is synchronized in bracket this, and the block starts here and ends here. So both the printing and the try-catch statements are included within that synchronized block. Synchronized this starting from here and it ends here. Now let's run this program. So you can see that only after the first thread prints the multiplication table of 6, the second thread will print the multiplication table of 100. Okay. Now there is another method by which you can implement this. That is, you can have a synchronized method. That is, in the print method, you put the keyword synchronized. So when you write the keyword synchronized here, this method will be locked. Only one thread can access it. When one completes it and exit, the other thread will work. So here, this is a synchronized method. I have included the keyword synchronized. Let's run this program. So you can see the first thread prints the multiplication table of 6. The second thread is printing the multiplication table of 100. So in this session we have seen what a thread is, what is a multi-threading environment, what are the different methods in Java to create a thread. Two methods are there, one is by extending thread class, one is by implementing null interface. Then what are the different methods in thread like mainly start, join, run, sleep, yield, etc. Then we have seen the synchronization, which is done with the help of synchronized block and also synchronized method. Hope you enjoyed this session. Thank you.